Section 10.2, correlation. So correlation exists between two quantitative variables when the values of one quantitative variable are somehow associated with the values of the other quantitative variable. So when you see a pattern in the data, you can say that there is a correlation in the data. But again, keep in mind that this is just for when we're looking at quantitative data, two quantitative variables. So although this book is only dealing with linear patterns, patterns can be other math models such as exponential, logarithmic, or periodic ones like sine and cosine functions. So to see this pattern, you can draw a scatter plot of the data, which is what we did back in section 10.1. So remember to read graphs from left to right the same way you read words. So if the graph goes up from left to right, the correlation is said to be positive. And if the graph goes down from left to right, the correlation is said to be negative. Now, the words weak, moderate, and strong are also used to describe the strength of the relationship between the two variables. As a student in an intro class, knowing what those numbers need to be for those particular ranges are not really defined. So we're going to be, again, looking at data that either when we look at the thing, it looks like, look at the scatter plot, there's a really strong relationship or a pretty weak one, so we don't have to worry about this kind of fuzzy gray area of moderate. So figure 10.2.1 shows the correlation between two variables in some of these graphs. So if we've got, again, two quantitative variables that we've plotted in the xy plane, and we kind of get some scattering here about a linear function, so kind of in the middle of the road, moderate and positive. It goes up from left to right. This graph also goes up from left to right, but again, these points, if these were drawn with the same scale, tend to be clustered closer to a line, so stronger than this one, so a strong positive linear correlation. And here, this one, if we were to play dot to dot with these points, we would get a perfect line here. So this is perfect, and again, it goes up from left to right. So perfect positive correlation. Here we've got a pattern in the dots that goes down from left to right, so we would say there's a negative correlation, versus in this one where we've got kind of points all over the place, there doesn't seem to be any linear pattern or any pattern at all, so we would say there's no correlation here. These points definitely have a correlation. Okay, there's a pattern to the data here. It's just not a linear one, which is what we are going to be focusing on in this particular class. So in looking at these and trying to decide how strong that relationship is, we need a numeric way. Instead of just looking at points in a plane on a scatter plot, we need a numeric way to measure the strength of the linear relation, because that's the one we're going to focus on, between two quantitative variables. And this measurement needs to be unitless. Because if somebody measures heights in inches and weights in pounds to see if there's a correlation between height and weight, but someone else takes the same group of people and measures heights in centimeters and weights in kilograms, then whatever we use to measure the strength of the relationship between height and weight should be the same. Okay, it should not depend on the units that were chosen to measure the data in. So the strength should not depend on the units of measurement. So what statistic do we have that's unitless from way back in the first chapter when we were dealing with data that had units were the z-scores.